Hi guys, welcome to lecture number 3 for PyTorch. So today I'll be specifically discussing regression. And guys, we are getting started, right? In the first lecture we saw how do we need to use tensors and some bit of back propagation. And now in the next lecture also we saw back propagation just to give you a start on it. And now we are moving to the first task, that is regression. But guys, essentially before we move to regression, always be clear in this point that when neural nets are used in regression, the only two things when you want to have is that when you have a large amount of data and all your previous ML techniques are not yielding great results. So let's say you've tried with every bagging, boosting and normal linear regression and you're able to find out that the accuracy is not matched, so you would go for a neural net, and we would be implementing one neural net specifically for regression and PyTorch, and then I'll be giving you a complete walkthrough of the code line by line. So let's just try to see what we are doing. So for the first part of it, the part is about importing libraries, that's clear. Then we are just setting some random seed for reproducibility. So guys, the main thing is that if you set this thing so not again and again, the numbers that would be generated will be different, but that's okay. So now we are creating some dummy data. We are creating X and Y. So X is this and Y is this. So you could just print out X and Y to get to understand what we are doing, but yeah, we are just creating some random data so that we can fit a regression model. So now the first thing that you need to understand is that torch dot float tensor x dot reshape -1 1. So guys, I have seen a lot of people implement stuff in PyTorch, but they don't understand. So the first thing is tensors, right? So in the lectures I've been talking about tensors, that why they are used. So always remember there are two aspects of tensors. One is that there is a lot of mathematical computation that goes behind a neural net, right? You have to just do a lot of matrix multiplication, optimizations and stuff. So tensors are best suited for that. And also tensors speed up the process of the entire training a neural network and back propagation via GPU. Okay, so that's why we need to use tensors first. Then guys, x dot reshape -1 guys, this is very important. So always understand that neural nets typically want you the data to be in this format, that is samples comma features. So how many features right now we have a simple x comma y kind of a data set, hence we just have one feature. Okay, that is why we are just reshaping it into -1 and 1 so that we just have a sort of a column vector. Okay, the length of it is 2000 and the number of features is 1, so that is why we have converted x and y into a similar format. Okay, this is very basic stuff, but you need to understand. Then even the question is float tensor. So guys, see, essentially we are trying to make sure that we use float 32 as our data type for all backend computation. This is good enough precision, and also the idea is to just make sure that everything is optimized in your neural network from a decimal standpoint. So we are using that, so we are good till there. And let's say that, so this is how is our synthetic data that's generated. So it's more like a polynomial curve. Yeah, it's a polynomial curve. Okay, and it is a polynomial curve, and this is the equation of the curve. Y is equal to 2x square plus 3x plus some noise. So now we are trying to define a simple neural network. Okay, so first of all we are importing torch, and then we are defining a simple neural network. So how it is going to look like. So in the first layer you will have one neuron, and then you will have that one neuron being connected to 8 neurons. So 1 2 3 4 5 6 7 8, then it would get connected to 4 neurons, and in the end you would have one neuron. So this is sort of the first simple neural net that I wanted to show you. So this is a very simple neural net, and post that we are using activation function as ReLU and activation function as ReLU, and that's pretty much it, right? You guys understand what happens inside a neural net, right? So it's f of x that usually happens, and x here is nothing but it's summation xi wi, right? So your data points get multiplied by the weight, and on top of that you apply a function, right? So f of summation xi wi you usually do. So that much is pretty much it, right? So now what is the model structure? So if you would see that this is the model structure that you have. So you have input features 1 and 8, then your input features are 8 and your output features are 4. So always make sure this matches and this matches, which is quite obvious if you understand basics of neural net. And The main idea is, guys, then we are having one neuron at the end that's going to just render the output for a regression problem statement. So now, guys, this was type of a simple neural network that I was using, but this didn't yield great accuracy. So I just upgraded the neural network over here, and now we are just have increased the width of the neural network and also the number of neurons. This is a very standard practice that we do. We try to play around multiple parameters, and slowly you will also understand. But yeah, you just need to understand that here inside this you need to define a neural net. As I said, this should match to this should match to this should match to this should match to this, for obvious reasons. And then, guys, the main thing is that you need to implement a better you need to implement an optimizer and a learning rate. So guys, see, essentially what happens inside a neural net is that you need to compute value of weights, and we usually do using gradient descent. So what is the gradient descent equation? Gradient descent equation is nothing, it's W new is equal to W old, okay, minus learning rate and rate of change of loss function with respect to W old. So guys, this equation changes when you use some sort of optimizer, right? Right now we are using Adam optimizer, there is RMS prop, there is other types of optimizers as well. So you can study about them, but mostly you will see Adam works really well, and that's okay. If you don't know a lot of optimizers as well, you can just go to chat GPT and ask it to change any sort of code, it will be able to do it, okay. The next thing is training. So guys, next thing is, this is how you define training. So in one, what is one epoch? So in one epoch, what happens is that we have defined epochs as 2000. So the main idea is that the entire data set would pass 2000 times. Like in one epoch it will see the entire data set, so in 2000 epochs it's going to see the entire data set 2000 times, and this is the forward pass. Then we are computing the loss. So guys, if you know a bit of regression, we usually define loss by MSC loss, okay. And once we have defined our loss function, we can go for backward pass, okay. Then we update the weights, that's what happens in a neural net. And then we have to just make sure that gradients don't get accumulated, so we are just writing 0 gradient for next step. And then, guys, we are just printing some sort of loss, and then we are just plotting our data and training the neural net. So guys, this was very simple example, but you're able to see how epoch by epoch the loss function is getting decreased, and if you will maybe train it for more epochs, you might find better accuracy. And see, this was the actual data, and this was the predictions which my neural net has done. So you're able to see how simple it is to train a neural net in PyTorch, right? All you need to take care of it is, first of all, you need to define a structure. Then you need to set up an optimizer. Here I'm using Adam with a learning rate of 0.00.1, so you can try it out with any learning rate. Usually I start with this, you can even go for 0.01, that's okay, and just experiments it, okay. The next thing is training loop. So you need to define a training loop. The next thing is that you need to understand that there would be a forward pass, there would be a backward pass, there would be a weight updates, and based on your weight updates, you need to just set 0 gradient for the next step, so that in the next epoch everything happens in a correct manner. That's how PyTorch works. And once you are testing the model in inference time, right, so you don't need to update the weights and inference time, you need to use this line, that is with torch dot no grade. You could just freeze the weights and just do the testing. And guys, you're able to see how efficient it is to train via PyTorch, right? So we are just starting out in this journey. All you need to understand is that what happens in a very generic fashion. Define the model, define the optimizer, define the learning rate. I have given you a complete walkthrough of the code line by line. Rest everything is irrelevant from the context of PyTorch. That's just plotting purpose, so you can go through the code. That's not a very big deal, right? So you can just take some time out and understand it. And yeah, I think just take out any other data set and try to implement regression in PyTorch. And guys, these type of things you will be doing in real life as well. If the volume of data is very high, you would be fitting a neural net for a regression based problem, that's for sure. And always be careful on setting up how you're defining the model, which optimizer you are using, what is the training epochs. All these things are very hyper parameterized, and you could try out with different variations, try out different stuff. So that's how usually it works. But yeah, you just need to be careful about understanding neural nets and then going to PyTorch, right? You're able to see that it's not very difficult to code things in PyTorch, specifically the way I'm teaching you. If you would go to my YouTube channel and you would just go to playlists, so there are like dedicated playlists, guys. So if you would go to my NLP playlist, there you would find one lecture for neural networks as well. See, neural networks is there. So if you want to understand, you can understand that as well, and let me know personally as well if you have any doubt. So that's the best part about this channel. You can DM me on LinkedIn and Instagram. I'll reach out to you. On that note, I would like to end our lecture 3 that was specifically covering regression and PyTorch. Guys, please subscribe to my YouTube channel. It's a humble request. Have a great day ahead. Bye.